Welcome to Chemistry Simplified. Our topic for today is conjugate acid base pairs. Let's say you're given this generic acid HA, let's call it acid 1. If that was to react with a generic base, referred to as B, so this is base number 2. So from Bronsted-Lowry, we know that an acid is a proton donor. A proton is nothing but a hydrogen ion. So HA as a hydrogen, which it can give away. So it's an acid. B, on the other hand, can receive that hydrogen. So it's a proton acceptor. So it's the base, based on what we had covered last time. So these two reactants would produce A minus, right? Because HA lost the proton, which was positively charged. So A has to be negative because HA was neutral. So that would be base 1. This is a base because it has lost the proton. Now it's a candidate to receive a proton. So therefore, it can act as a base, which we're going to be seeing in the next few minutes. Plus BH plus. Remember, B on the reactant side had received the hydrogen ion. So it's now BH plus. So we call that acid 2. Right? It's an acid because it has a proton that it can give away. That's exactly what we're going to see right now. Right? So it can act as a proton donor. Right? So it gives away that proton to A minus. A minus is receiving the proton, so therefore it's a proton accepted. That's why it is a base. And that reaction can go backward now to produce HA plus B. So this reaction is said to be reversible. Now, HA was an acid and A minus was its conjugate base. So therefore, these two would be said to be conjugate acid base pair. Likewise, B and BH plus are said to be conjugate acid base pair because B as a reactant on the left side had received a proton to become BH plus, right? And it can give away that proton to become a base as well. So these two are considered to be conjugate acid base pair. Now let's look at an example. Let's say we are given HF, which is hydrofluoric acid. If that was to react with water, the acid would give away its proton, right, to water. Right, water would be the base because it accepts the proton, and that would give us fluoride ion, which would be a conjugate base, plus hydronium ion, which would be a conjugate acid. So hydronium ion can donate its proton to fluoride ion, and that reaction will go backward to produce hydrofluoric acid plus water. Let's look at one last example. Let's say we had water reacting with ammonia. Water in this case would be the acid. Why? Because it can donate its proton. Ammonia would be the base because it accepts the proton. And this would give us hydroxide ion, which is a conjugate base, plus ammonium ion, which would be a conjugate acid. As a conjugate acid, ammonium ion can donate a proton to hydroxide ion, so the reaction will go backward to produce water, and ammonia. All right, thank you. This is our presentation. Let us know if you found it to be helpful. Please remember to like, subscribe, and share. Bye bye.